know. I'll keep you awake.
So this lesson is very short and sweet, and it's all algebra. There are no word problems. However, there is something you're going to have to remember in order to set it up to solve it, and I have a corny, weird way to help you remember it, so you're welcome. We are looking at solving absolute value equations, which are short, sweet, and then inequalities, which is where you have to remember something. Okay? Let's first remind you of what absolute value means.
The distance from
Absolute
zero.
value is the distance of a number from the origin, from 0, which is why it always comes out positive, because we're talking about its distance, right? The absolute value of 5 is 5. It's 5 units from 0. If you look at this yellow, clearly not, if you look at this box, the absolute value of x equals a is equivalent to, and then you see this right here. This is where some people get confused because they forget what the whole point of absolute value is. If I'm trying to solve this absolute value equation, I have to ask myself what numbers could have been in the absolute value bars to generate a positive a. Well, there could have been a negative a, or there could have been a positive a. And so that's how you set it up. It's 2 possible answers. To help you understand the graph behind it, alright, to help you understand the graph behind it, here is the mother function for the absolute value graph. You can see that it is splitting off in 2 different directions. If that graph were shifted down, it would cross the x-axis in 2 places, right? Okay. Let's look at this right here. Solve. The absolute value of x equals 5. Ask yourself, what is in here?
Plus or minus 5.
Yes, so x equals 5 or x equals negative 5.
Do you have to separate it like that, or can you do plus or minus
I write
5?
them as 2 so that people remember that they are 2.
Okay.
You can do the positive or negative sign if you want to. I don't remember. I think it asks for a comma. And it wants you to type them separated. Right? Yeah. So you would do 5 comma negative 5. Alright, that one was way too easy. So now let's go to one where you have to actually do some work. We have the absolute value of x minus 3 minus 1 equals 4. You did? I'm sorry, this wasn't Friday's lesson. Before I can set my absolute value problem up, I need to have the absolute value bars by themselves. Right now there's a minus 1 in there that needs to move. So let's make a note that you're going to isolate the, and then this is me writing the absolute value bars. So we're going to add 1 to the right. Now, don't focus on what's in the bars. Focus on what it has to equal.
5.
This is where people start to mess up. The absolute value of some crap, just call it crap, has to equal 5. So that crap has to either be, what number? 5 or negative 5. That's where you get your 2 equations. You're saying to yourself, this mess right here, oh my word. You're saying to yourself that this mess right here has to either be a 5 or a negative 5 in order for this to be true. And so you're going to split it and say, okay, so it's, I like to do the negative one on the left. Even though I didn't do that with the very first one, that's alright. Negative 5 or this crab is equal to positive 5. I got it.
Nancy Isabella.
She's on her way. That was you, isn't it? Now you have two equations. You're going to solve them individually. So I'm going to add 3 to the right. Add 3 to the right. And I get negative 2 or 8. Now, you really should not have any domain restrictions here because you can take the absolute value of any number. It can be positive, it can be negative, it can be 0. You can take the absolute value of any negative or positive or 0 type number. But if you wanted to plug it back in and check it, you could. Negative 2 minus 3 would be negative 5. Absolute value would be positive 5. Minus 1 is 4. 8 minus 3 is 5. Absolute value, that's 5. Minus 1 is still 4. So we have two answers.
Sure.
Okay, go to the next one. You try it. What do I need to do to start?
Minus 12.
The bars by themselves.
The bars by themselves. There are two things to accomplish to get the bars by themselves.
Would you have to divide by the negative once you move the 12
and it's
over?
not going to affect the absolute value of x plus 6. It just goes to the other side. Please don't add 12 to both sides. Some people look at these problems too quickly and they just see a 12, they see a minus, and then they'll add 12. If I add 12 to both sides, I would end up with 24 on the left, which is not helpful. So look at the sign in front of it right here, you know, it's positive. So I'm going to subtract. And then that is a negative 1 in front of the bars attached by multiplication, so I can move it by division, or because it's negative 1, I could multiply it by negative 1. If that confuses you, just move by division. So that negative would go away. It does not affect your absolute value bars. They're protected. I like to multiply. But if I can multiply instead of divide, I don't know. I prefer multiply. Huh? Because it's 1. 1 doesn't change anything.
It just takes away the negative.
It's the same thing. You can only do that with 1, by the way. 1 and negative. Alright, now we're at bars by themselves equals a number. Remember, you're not focusing on what's in the bars. You're focusing on what they're equal to. So this crap has to equal 7, which means that crap is either what number? Oh, wait, not x. What does this crap have to be? Either 7 or negative 7. Do you see it? Okay, so set them up. Oops. So x plus 6 is negative 7, or x plus 6 is positive 7. And then solve those. What do you think? Not bad, right? Now, the inequalities are the same concept, but because it's an inequality, there is shading involved.
You have to flip
Which
the
is-
sign.
Yeah, you're going to have to also remember that if there's a negative number moved by multiplication or division to the other side, flip your sign so you don't get an inaccurate answer. We're going to practice normal ones, then we're going to practice the special case examples, and then we're done. On your paper, on this slide, it is laying it out for you the two scenarios. Either you have the absolute value of something is less than or equal to, that could also be or equal, but less than, or you have the absolute value is greater than. You know how when it was equal to, we had to set it equal to the two possible numbers, right? The ones we just practiced? When it was equal to a number, we set it up as equal to that positive or that negative, right? Okay, now that it's either less than or greater than, we have to set it up as either as a specific compound inequality. It's either an or an and. There's only two types of inequalities, or and. We've practiced this before. I've related it to go to the store and get me a Coke or a Sprite. Well, that means you could get either one, right? Or both, if you wanted to. But if I said go to the store and get Coke and Sprite, that means you have to pick up two items. See the difference between the two? Or has more values. And is more restrictive, smaller values, because you have to meet more conditions. If it's a less than inequality, watch this. It's less than, and you do need the bars on the left for this trick to work. If it's less than, you set it up as a compound and inequality. You will notice that the crap in the bars gets put right in between the negative and the positive with the signs facing this way. Notice the signs are the same. Do you see that? They don't flip or anything. This is an and inequality. If it's greater than, you set it up as an or inequality, which means you have two totally different inequalities. You have the crap is less than the negative, or the crap is greater than the positive. This is what you're going to have to memorize. Let me help you. In terms of graphing, this is an and inequality. Here, I'll put this. I'm going to put it above it. All right. So I'm going to draw. Hold on. Sorry. I'm going to draw a number line, and I'm just going to put arrows. An and inequality means there's shading in between two values every time. An or inequality means you're shading on the outside every time. Look at the difference. Look at the difference in those two. Stay with me. Don't fall asleep. And means more restrictive. It's got to be greater than this lowest number and at the same time smaller than the high number. So it's got to be in between. Or means it's got to be to the left or to the right. Okay? And that's how your answers will always look as well. Unless there's a special case scenario, which I'm going to show you that. Now, how in the world are you going to remember this? This is so stupid. All right, you ready?
I do agree. It is kind of stupid.
If it's a greater than inequality, I want you to, my arrow here, by the way, means think. I want you to think the great outdoors. You ever heard to nature as being called the great outdoors?
Yes.
Okay, why do I say outdoors? Because look at the graph. What am I shading? The outer ends, right? I feel like I'm trying to fly. I'm shading the outer ends, okay? Whereas less than, not than, come on. Less than, I want you to think between. So, if it's greater than, it's the great outdoors. Which means if you have two shaded sections, you should have two inequalities. You with me? You should be working on two sides, two separate inequalities. And then if it's less than, I want you to think between. Between. Okay. Which means one inequality, one shaded section, and the value, the crap is in the middle. It's in between the signs. Okay, how do you set it up? Like this is the setup. Now watch it in practice. So if I was to solve the absolute value of x is less than 3, I would say less than, that means between. So that crap right here is in between the negative and the positive. Negative should always be on what side? Left. Positive should always be on the right. Don't confuse those. Then that would be done. There's nothing to solve there because that was just x. So that's done. In terms of what it would look like if you were to graph it, that would be this. So it's between -3, +3, open circles, shaded. Interval notation, it would look like this. Ooh. I about did a bracket. There you go. Interval notation, it would look like that. While this may seem heavy, and you're like, okay, Ms. Holcombe, this was going really good, and now you've done this. While it may seem that way, please don't turn your nose up at checking your answer really quickly. You can check it in 15 seconds, if that. Pick a number from your shaded section. I'm going to pick 0. 0 is right here, right? Plug it in. Is 0, what's the absolute value of 0? 0. Is that less than 3? Yes. So then I have it correct. Okay? Check your answer. All right, look at the next one. If I had the absolute value of y is greater than or equal to 1, greater than, great outdoors, so I'm shading the outer regions. The negative is over here, the positive is over here. So that's where it's got to go left of the negative or greater than the positive. Do you see that? Inequalities are always, well, they're stressful because you should have had plenty of practice for it, but some people still struggle reading inequalities. So I'm trying to read the room right now on if y'all don't get it or you're just tired.
I'm tired.
Okay.
I'm tired.
They would be closed. Yes. Yes. And the way this would look, since it's going -1, so that's closed, going that way, closed, going that way. This one has 2 shaded sections, so I would have to write 2 interval notations. From left to right, it's -infinity to -1, then 1 to infinity. That's what it would look like. But I don't think, oh no, they do. Yeah, they want you to do all 3. Write the inequality, write the interval, show the graph. All 3. All right, 5 slides left. Okay, so this one dives into another example, but we don't actually solve it here, so we'll just go to the next slide where we actually start solving them. But this is a less than. Less than is in between, so I put that crap in between the negative and the positive 4, right? Brody?
I'm listening.
Get uncomfortable. You're falling asleep. There you go. Alright, so let's try this. Go over here. Let's start simple. Start simple. How do you solve it? You have to set it up. That's how you solve it. That's why some people struggle with this. They don't realize there is a setup process. How do you know how to set it up? It all relates to what sign it is. And by the way, my trick only works if the inequality is on inequality. Absolute value if it's on the left, okay? Because you have to read it from the x expression. So the absolute value of x is less than or equal to 2. Less than means between. So I take this crap and I put it in between the exact sign that I saw right there. It's in between. Now what needs to be on the left?
Negative.
Negative 2. What needs to be on the right?
2.
Positive 2. And then you would technically solve it, but there's nothing to solve. This was just x. We are going to practice when there is solving. I just need you to know how to set it up. Now let's write it in interval notation or graphic. Either one you want to do first. Negative 2 to 2. Open or closed? Closed. Shade in between. Which is exactly why I'm trying to teach you. Less than means in between. Interval notation would look like this. So you have 3 ways to represent the answer there.
Why is that
This is shaded on the outside. You're fine. Start recognizing how many shaded sections there are, because that is a giveaway to how many interval notations you have to write. So I have 1 shaded section, I'll have 1 interval notation. I have 1 big inequality. They all correspond. All right, let's do the next one. This is greater than, so this is the great outdoors, which means that my final answer should be shading on the outside. Now here's where you've got to have number sense. You should know negative numbers are on the left, positive numbers are on the right. If I'm trying to shade outside of those, then you should know that this crap has to go less than the negative, right? Shading that way, or to the right of the positive. You've got to have that number sense. By the way, it is always that way. It's always less than the negative would go that way, and greater than the positive would go to the right. Now, what does it look like shaded? Negative numbers are on the left, positives on the right. These are open, open. This says go left. This says go right. Hence the reason we call it the great outdoors. Shading on the outer parts. Interval notation. How many shaded sections do I have?
2.
2. So how many interval notations will I have?
2.
2. Just make sure to dodge it. It would probably help to label your number line with your negative infinity and positive infinity, because then you're just reading it like a book from left to right. Negatives on the left, positives on the right. Here we go. Negative infinity to negative 7. That is open. Skip. 7 to infinity. Okay, that is the foundation of what we are about to do. It's just the difference is once we set it up, we now have to actually solve for x. X was already by itself here. So nothing else is changing. You with me? Everything else is the same. That's how you set it up. So that slide is the most important. This is how you set it up. Now let's go to where problems are not already x by itself. Solve and graph. The absolute value of 3x plus 2 is less than 5. Less than means between. So at some point I'm going to have something between two values, right? How do I figure it out? Set it up. Set that crap in the bars between, what's on the left? -5 and +5. Alright, so here we go. Set it in between. 3x plus 2. You need to space it out so you can see that it is in between the negative and the positive. Notice my inequality signs are not changing position for the between setup. If they change position, then it's no longer reading correctly. Now, this is new. You're solving this. You have 3 compartments. If you need to draw a highlighter, y'all remember this? If you need to draw a highlighter down the inequality signs so you can see, okay, I got the far left, I've got the middle, and I've got the far right. You work from the middle, because that's the one with x. We need x by itself. And whatever you do to the middle gets repeated on the left and the right. So I'm going to subtract 2. And I end up with -7, copy the sign, 3x, copy the sign, 3. Then I'm going to do what? Divide by 3. So when I come under here and divide by 3, and under here, and under here, on the left, I'm going to leave it as -7/3 because my math lab does not like decimals. On the right, it would simplify to 1. Now, in terms of graphing it, you would have to go to your calculator and do what's -7 by 3, because I don't know where that is. You know, if it were -6 divided by 3, that would be -2, but it's -7, so you can kind of calibrate, okay, it's a little past. But to take the thinking part away right there, since that's a technicality, go to your calculator, -7 divide 3. Get the decimal. It's -2.3 repeating. Okay, so I'm going to come underneath it and put squigglies like -2.3 repeated. So when I go over here to graph it, I'm not putting it on -2. I'm not putting it on -3. I'm putting it just in between them. So, let's see, I'm going to label this as 0. I'll call this 1. This would be -1, -2, -3. All right, open on 1. Open on -2.3, so it's about right there-ish. And we're shading in between. The interval notation would be the fraction form. So -7/3 to 1. That is the interval notation. We have 3 slides left. Okay, let's do the next one. 5 minus 2x is greater than or equal to 1. Greater than means great outdoors. So we're going to take the crap in the brackets and we're going to put it as 2 totally, remember me up here doing this silly like move with my hands. You got 2 totally different inequalities, okay? How do you set it up? You've got to have the number sense that this crap is going to be less than or equal to the negative. That one you have to actually remember. It's going to be less than or equal to the negative. Or, and then you will notice that that exact expression gets copied for the right-hand example.
You can just remember both of the sign change. It's just the opposite sign. Or like it would be a negative, it would be a sign.
Oh, I see. You're
That's what
saying
I'm saying.
two things to change.
Right.
Yeah, that's
So
fine.
we go from one.
I've shown people that if you notice on the right-hand side, it's always the exact same. And then I've had people only put that as their work. They completely forget the left case scenario. So please remember, great outdoors means two cases, okay? This is the one that you've got to memorize. That's some most common mistake. People leave this one off every time, and then that means half credit. All right, let's solve them. I'm going to subtract 5. I wish there was like a bell that I could like ding, 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 ding. Right here, I need to divide by -2, divide by -2. And what do you notice?
Let's put the flat down there.
Not a red flag. It does not mean no swimming in the ocean. It means watch out. There's a sign change here. Watch out for the Rubbermaid container on the interstate on I-75 that damaged your car. All right, I'm going to clean this up. So those would cancel. I'm going to flip the sign, and that would be +3. Those would cancel. I'm going to flip this. Oh, I didn't flip it. I'm going to flip the sign, and that would be +2. My paper has 10. That says 1.
Your paper's wrong.
All right. So let's go to graph it. You've got to be able to read it. Read it from the x. X is greater than or equal to 3. That means find 3 and shade to the
Right.
right. I'm just going to put 3 right here. Find 3, shade to the right. Then this says x is less than or equal to 2. I hate to put 2 right next to it, but I'm going to. And then it's closed, and it's going less than. Right? Then put your infinities. So now you can read it from left to right. We got negative infinity up to 2, bracket, skip, 3 to infinity. Two left, and they are the special case scenarios. When you're solving equations, what are the 2 types of special cases? Do you remember? Oh, come on. What?
Infinite, or many, and no solution.
Yeah, but who?
Extraneous.
I said that. Okay.
She said it.
The 2 special case scenarios when you're solving equations is infinitely many solutions or no solution. Same thing with inequalities. Now, how do you know when you're dealing with which one? You have to go and graph it to realize what's happening here. Infinite would mean the entire number line has just been shaded. No solution would mean there is not a shaded section at all that satisfies the inequality. All right, we're going to do one of each. The beauty of it is this. And I haven't pointed this out to you yet because I wanted you to actually know how to solve it algebraically before I tell you to read it and think before you solve it. Now look at it from the beginning. We have the absolute value of 7 minus x is greater than or equal to negative 4. When you go back to all of our examples, what have they always been less than, greater than, or equal to?
A positive
A
number.
positive number.
This doesn't work.
This is a negative number. I need you to zoom out with your mind. Right here, I need you to focus on this crap and think to yourself, this, make this note, this always produces, right? Not comes from. We're saying it always produces, yields, results in a positive number. What comes out of absolute value bars? Every time it's a positive number. So how in the world am I greater than or equal to a negative number? That's your indication there's something fixing to happen.
It's no
Okay.
solution.
What'd you say?
No solution.
Alright, so watch. Let's make a note.
Be a solution.
The number on the right is negative. Ooh, spell it right. Is negative, comma. So something is true or false all the time. Something is true or false all the time. Now, here's the big picture. You ready? And this is not enough to do on my math necessarily. Like, you need to be able to solve it too. What always comes out of this crap?
Positive.
Positive number. Quit focusing on the x minus 4. You see it? Quit focusing on the x minus 4. Just imagine it always spits out a positive number, right? Okay, so a positive number, I'm replacing that crap with a positive number. I'm copying the rest. True or false? Positive number is greater than or equal to negative 4. True in every sense of the word. Right? Which is exactly why this is going to be an example of infinitely many solutions. Now, let me show you the math behind it, though. That was a lot to take in. This was us reading it as a blurred crap, absolute value expression, greater than or equal to a negative number. Well, that will always be the case because that only produces positive numbers. Now, what's the math behind it? What if you forgot to actually read it before you started it? Let's do the math. This is a great outdoors, right? All right, let's set it up. So this crap has to be less than the negative. Well, what do you notice? Less than the negative. What do you notice about it? It's already negative. So when I go to make it negative, it's actually going to change it to positive. I'm going to leave that there so you can see why. Remember, we said less than the negative, greater than the positive. Or it's that crap is greater than the positive, which means what's already written. This is another indication like something weird here. Like as you went and set it up, you should notice right here there's something weird. Yes. Now let's clean it up. That's actually positive 4. And there's nothing to clean up there, right? I'm going to subtract 7. If I subtract 7, here, subtract 7. With me?
Subtract 7.
Taking mental notes. Now I need to, what? we go. Watch out. Gonna divide by -1. Or multiply it by -1, whatever you want to do. We're going to flip the signs. Now we're going to go graph it. Here's where, once again, you've got to have number sense. You've got to know, like, on number lines, where numbers are, what the inequality signs mean. You also have to remember this was an OR problem. OR means you can go that way, you can go that way, you can go both ways, I don't care, it doesn't matter. So I'm going to shade greater than 3. Closed. Shade greater than or equal to 3. Right? There was no restriction. It was just shade greater than or equal to 3. Now I'm going to go to 11, close, and I'm going to shade less than or equal to 11. What happened?
Okay, crossed.
The whole number line got shaded. So infinite solutions, which means in interval notation, negative infinity to positive infinity. Now I'm definitely doing this next slide because it's not as lengthy, so make sure you're staying with me.
Totally staying with you.
Huh?
I'm totally staying with you. I'm paying
Okay.
attention.
If you go to the next slide, go ahead and read it to yourself. Blur out the inequality, blur out the absolute value part. Just read it as this is going to produce a positive number.
Uh-huh.
This is going to produce a what? This is going to be a positive number. Can that be less than -5? No. Positive number less than -5 is false. So it's going to be a no solution problem. Now, what does it look like if you didn't read it from the get-go? Here's what it looks like. This is less than, so this would be between. So you're going to set that between the negative and the positive, which is where things get weird, because it's already negative, so when I go to set it between the negative and the positive, they get sign changes. So 2x minus 4 between the negative, -5, and the positive, which is negative. See it now? So I'm going to solve this. Add 4 to both sides. Then do what? Divide by 2. I'm going to write this as decimal, just graphing. 9 over 2 is 4.5. If I go to try to graph this, you'll notice that things have switched. That's another red flag. Like my negative is no longer on the left, my positive is no longer on the right. Something is not right here. But if I try to graph it, here's what happens. This is saying you need to shade greater than 4.5 and at the same time less than -0.5. So visualize that. Greater than 4.5 and at the same time less than. Do those overlap at all? No. So So there's no overlap, which means there's no solution.